Okay, welcome back. We're going to work out some coordinate geometry problems, and these are the formulas that we're going to use. So it might be helpful to have a formula sheet while you're working some of these out, including distance formula, midpoint, finding the gradient between 2 points, equation of a line in point gradient form, how to find the gradient if it's written in a general form like this, and also parallel and perpendicular gradients and what their relationships are. So we'll keep this handy while we work out a couple of problems. So let's go. Okay, the first thing we're going to find is the equation of line AB using these two coordinates right here. So let's write down these two coordinates and calculate the gradient. Okay, coordinate of A was -2, -2, and the coordinate of B was 0, 4. And using my formula sheet, which we should be familiar with, the gradient here is change in y over change in x, and that's what I did right here. 4 take away -2 is the change in y, and 0 take away -2 is the change in x. That gives us 6 over 2, which simplifies down to 3. Great. Our next step is to use the equation of the line formula, the point gradient, to write the equation using either one of these points. And I think I'll use this point because it has a 0 in it and it'll make it a little bit easier. So let's do that. Okay, after I substitute my values in, here's x1, here's y1 from this coordinate, and here's my gradient. So now I'm going to want to write my equation in this form right here, which means I need to rearrange this equation. So let's do it. I expand on the right, and 3 times 0 just gives me 0. Now all I do is to rearrange and put everything on the left side of the equation, starting with the x term. So let's see what I get. Okay, and after I rearrange it, I get -3x plus y minus 4 equals 0. Alright, let's try the next one. Find the equation of the line that passes through C, through this point, and is parallel with AB. Okay, that's pretty easy because if two lines are parallel, they have the same gradient. So I'm going to use the gradient of 3 that I got earlier and use this point of C, and let's get the coordinate of that, which is 2, 0. And all we do is enter 2, 0 for our coordinate here and 3 for my gradient and write the equation. And we'll do that right now. Okay, and that's my equation of the line that goes through C and is parallel to AB, and of course they should have the same gradient. Okay, let's read the next question. Find the equation of the line that passes through C and is perpendicular to AB. So perpendicular lines, the product of their gradients must equal -1. Not +1. Let's change that. So let's work that one out. Okay. Okay, so I have my notes. If the gradient of AB is 3, then the perpendicular gradient must be -1/3, because if I multiply these two together, I get -1. So this is the gradient that I'm going to use in my equation when I enter it in here. Okay, so let's do that. Okay, so that's my equation when I substitute everything in. I use the point 2, 0, which is C right there, and I use my gradient of -1/3. And now I want to write the equation in this form. So the one thing I need to do first is get rid of that fraction here, because in the general form, A, B, and C can't be fractions. So in order to do that, what I'm going to do is multiply both sides of the equation by 3 to knock out that fraction. So I'm going to multiply this by 3, and I'm going to multiply this whole side by 3. And when I do that, on the right side, these 3's cancel out, and all I'm left with is a negative 1 to expand through. Now over here, I'm just going to expand that 3 through, but 3 times 0 is 0, so I'm just left with 3y. And I'll expand that negative 1 on the right side to get negative x plus 2. Now all that's left is to rearrange and get all of these terms on the left side of the equation. Let's do it. I get x plus 3y minus 2 equals 0. When I take the terms and move them to the opposite side, their signs change. Okay, let's look at the last question. Show that the triangle with vertices ABC is at right angled and isosceles. So we have two things to do here. We have to show that this triangle that we draw from A to C to B has a 90-degree angle in it, and also that two sides are equal. So let's just let's connect those vertices right there just to get an idea of what it looks like. Okay, so the first thing I'm going to do is I'm going to find the gradient of AC, and I'm going to find the gradient of BC, and I'm going to see if they multiply to get to negative 1. So let's try that. Okay, so for the gradient of AC, I get 1/2. And remember the coordinates I used, C is 2, 0, and the coordinate for A is negative 2, negative 2. So now let's try BC and see what I get for the gradient of that. Okay, and for the gradient of BC I get negative 2. And in order to prove that they're perpendicular, I multiply the two gradients together, and if they equal negative 1, then they're perpendicular. Therefore, AC is perpendicular to BC. And it kind of looks like a right triangle, so let's put a 90-degree symbol in there, now that we know for sure. Okay, now my next step is to prove that it's isosceles, so I'm going to use the distance formula to prove that BC is equal to AC. And I have the coordinates for all of them, so I'll just write them in. 0, 4, 2, 0, and negative 2, negative 2. So, first, I'll find the distance of BC. Okay, so using the distance formula for BC and plugging in my coordinates of BC, I get a value of square root of 20, and I don't need a decimal approximation for that. I can just leave it as square root of 20 for now. And when I use the distance formula for AC, I get a value of square root of 20 as well. Now, if you don't want to use the distance formula, you can always use Pythagoras, because the coordinates that we have aren't decimals or fractions, and it's quite easy to look at this as a right angled triangle. So BC is just the hypotenuse of that right triangle right there, and AC is the hypotenuse of that right triangle right there. These have sides 4 and 2, and these have sides 4 and 2. Both give you the square root of 20. So all the distance formula is, remember, is just figuring out the hypotenuse of a right triangle from Pythagoras. So we can come to our conclusion write it out. AC equals BC. Therefore, we have an isosceles triangle and a right triangle. Okay, that's it for now. See you next time.